Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 6.1.4, starting with the M&Ms. For graphing inequalities, there's a process that we go through, and one of the processes that we do is when you're given an inequality, treat it like it's an equation, okay? When you solve the equation, solve for x, you're going to know what your boundary point is for your graph, for your solutions, for your inequality. So we just take it and we're like, okay, what is, if x minus 4 is equal to 8, and what was x before we subtracted away the 4? Well, we would add 4 to each side, and we would see that x would have to be equal to 12. So we circle that point on the line. Then we treat this like it's an inequality. Instead of it being x is equal to 12, use this inequality symbol and say x is greater than or equal to 12, which means we are going to be shading everything that is greater than 12. And just like with the 5D process, when making the decision, you go through the process of doing the problem and then you decide whether or not you got your answer right. Well, we want to do some sort of a check here to just make sure that both our boundary number and the section that got filled in, shaded in, is truly the solution. So I noticed that they tested the number 8 and 15. I would tend to test the number 0. And so if you plug the number 0 in here, would 0 minus 4 be greater than or equal to 8? And the answer is no, absolutely not. And since 0 is on this side of the number line, if 0 is not a solution, that means nothing over here is a solution. So that means everything on the other side has to be a solution. So you can really test one number, and my big number I generally check is 0. If it works, and it's supposed to work, you shade in that side. If it doesn't work, then you shade on the other side, right? So let's check that out with problems like what we have right here. So when we take 3x minus 3, 3x minus 3 is less than 2 minus 2x. Remember, we're treating this like it's an equation. So just go through the process. I generally want to collect the x's on the side that have more x's. And to determine that, look at the coefficient, okay? If I change this to plus a negative 2x by doing KFC, 3 is greater than negative 2. So it's in your best interest to collect the x's on the left-hand side. You'll learn later on why it's in your best interest to do that, because there's this process where if you ever divide by a negative number, you have to reverse the inequality symbol, and that's very confusing. It's a rule that people often forget. So if you just get into the habit of always collecting your variable on the side where you have more variables, which means the greater coefficient, then you will be fine and you won't ever have to remember that rule. So let's add 2 x's to each side. That gives me 5 x's on the left-hand side. Had I taken away 3 x's from each side, I had a negative 5 x's on the right, and I would have had to divide by a negative, which would have caused that complication. So this zeroed out. Now you got 5 x's. Let's go ahead and leave this how it is and add 3, because we know we want to get our constant on the right side now. And so the negative 3 and the 3 make a 0 pair, but the 2 and 3 make 5. So now we'll finish it off by dividing each side by 5, so you get x is less than 1. Now remember, checking for 0. 0 should be a solution because 0 is less than 1, correct? So if I were to plug 0 in here and simplify these two expressions, this side should be less than this side. That should make it a true statement. So what is 3 times 0? That is 0 minus 3 is negative 3. And 2 minus this ends up being 0 because 2 times 0 is 0. 2 minus 0 is 2, and negative 3 is less than 2. So yes, 0 is a solution, and everything else on that side of the 1 is a solution. If you want to test the number 2 in here just to prove that it doesn't make it correct, you're welcome to do that, right? 3 times 2 is 6, and 6 minus 3 is 3. 2 minus negative 4 is negative 2. 3 is not less than negative 2. So 2 does not work. 0 does. We shade it in the proper direction. For this problem, this is a little bit trickier than some of the other problems. 4/5 of something is a boundary number of 8. I'm going to remind you that our goal is always to get one x all by itself on one side of the equation. And when you've got a term like this, if you want to change that coefficient from 4/5 to 1, we're going to use a strategy that we learned about when we were dividing fractions. Anytime you divide a fraction or any number by itself, you always get 1 for an answer. And instead of dividing by fraction, if you multiply times the reciprocal, you will also get 1 for an answer. So 5 times 4 is 20. 4 times 5 is 20. There's your giant 1. So you end up with x is greater than or equal to whatever 8 times 5 over 4 is. Remember, whatever you do to one side of the equation, you must do the exact same thing to the other side to keep everything balanced. So 8 times 5 is 40. And remember, that's a numerator times numerator. Denominator times denominator is a 4. So 40 divided by 4 is 10. So we think 10 is going to be the solution. So we're going to write x is greater than or equal to 10. So now, every number that's greater than 10 goes to the right. Our boundary number was the number 10, and we think, well, we know because it's greater than or equal to 10, we'll shade that in. How do we check to make sure that we've shaded in the proper direction here? Well, test 0. In this case, 0 is not supposed to work, right? We think it's supposed to be on this side. So if I plug in the number 0 here, anything times 0 is 0, and is 0 greater than 8? No, it is not. It shouldn't be the solution, right? So if nothing over here works, everything on this side will work. Now, if you want to test like the number 15 or 20 just to make sure it works, you can do that. Let's say 4/5 times 20 over 1 is supposed to be greater than or equal to 8. Well, 4 times 20 is 80, and 80 divided by 5 is equal to 16, and 16 is greater than 8. So yes, this side has all the solutions. All right, here, basically determine which one of these numbers is the solution to the inequality. Solve your inequality, and then how does this number compare to 4/5? Is it less than? No. Is this one less than 4/5? Yes. And how do we know? Because 4/5 is the same as 8/10, which in decimal form is 0.8. This is 0.5, so 0.5 is less than 0.8, so that would be a solution. -3, obviously, because it's negative and this is a positive, so yes, all negative numbers are going to be solutions. And then 2/3 is 0.6 repeated, and that is also less than 0.8. So we know that if you plugged in this here and here and simplify those expressions, this value would end up being less than this value. All right, now we are evaluating expressions. Whenever you evaluate an expression, you just plug these numbers in and then go through the order of operations. In algebra, when you've got variables being multiplied together, you just put them side by side, no operation symbol in between. So when I replace those with the numbers, we're going to have to put the parentheses there, which means we're multiplying all the numbers together. And -2 times -5 is +10, and 10 times 3 is 30. Here you got a -5 plus a -2, right? -2 plus -5 is -7. And then you multiply that times 3, and you get -21. And then here, z is equal to 3, so it's going to be a 5 in the numerator. Y is equal to -5, so that equals -1, and -1 plus 1 is going to give you a 0 for your answer. Here's a perimeter problem, pretty straightforward. We don't have to worry about any subtracting or anything. So you got 4 x's and 4 1's. And so if you're going to find the perimeter for these values for x, you just plug them in here. 4 times 7 is 28, and 28 plus 4 is equal to 32. For this one, 4 times 5 is 20. 4 times a half is 2, so 4 times 5 and a half is going to be 22 plus 4 gives you 26. This is kind of a fun problem for those of us that enjoy challenging little puzzles. Here we get a part of a 5D table. And your task was to kind of look at the situation and determine, all right, what could be a word problem that we could write given these examples here? And so I immediately thought, all right, we got 3 variables, right? And we got a total, which is 74. And what's the relationship? This one would be like our x. And this one is 2 times x, right? And this one is 2 more than whatever x was, right? So we start with a number, double it and then add 2 to it. And when you add all 3 of those numbers together, you get your target of 74. So I immediately started thinking of people's ages. You could have done anything, but I just made up some names: Sarah, Mary, and Jeff. Sarah, no, Mary is twice as old as Sarah, and Jeff is 2 years older than Sarah. When you add all their ages together, it equals 74. So let's go ahead and work through the process. Turns out when Sarah is 18, Mary is 36, and Jeff is 20, and you add those 3 numbers together, you get 74 for your answer. So yes, this is the question that I presented. Jeff is 2 years older than Sarah, and Mary is twice Sarah's age. All of them have a combined age of 74. How old is each person? All right, Beth is filling a small backyard pool with a garden hose. The pool holds about 30 gallons of water, and after 5 minutes, the pool is about 1/4 full. Okay, so it starts off empty, I'm presuming, and it increases by 1/4 every 5 minutes. So I'm thinking 1/4 in 5 minutes, 2/4 in 10 minutes, 3/4 in 15 minutes, and 4/4, or it's full in a total of 20 minutes. So let's look and see what the question is asking us. Assuming that the water is flowing at a constant rate, about how much water is going into the pool each minute? Ooh, okay. So if it's 30, it's got a total of 30 gallons, right? And in 5 minutes, what did we say? So if it's 1/4, what is that? That's got to be 7.5 plus 7.5. That's 15 plus 7.5 plus 7.5 gives us a total of 30 gallons. Then we're going to say, I'm going to change that then. Or I guess I could do this. I could say 30 gallons in 20 minutes is how many gallons in 1 minute. I could have also taken 7.5 over 5. That would have worked as well. So what is 20 divided by 30? 20 divided by 30 is 1.5. So that means it's 1.5 gallons each minute. We already answered this one. How long would it take to fill the pool? It would be a total of 20 minutes. And that's it. That is it. All right, let's move on to the next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.